Hello, students. So, in this session, I'm going to give you a general idea of machine learning. Now, the human brain, it learns from experience. This experience, it comes in the form of data. So, the brain, it becomes better with more data. So, the type or quality of experience or the data that dictates what that person is going to become. For example, if you have been studying arts, you become artist. You've been studying music, you become musician. If you know more about plants, you've been studying flowers, plants, you become botanist. And so the machine learning model, they work on exactly the same principle. You have data, you feed to the machine learning model, it becomes trained. In other words, it becomes expert in that. So for example, let's say you feed iris flower dataset. This one contains all the information about iris flower, the dimensions and so on and so forth. So when you feed this data to your model, this model is going to become expert or trained on iris dataset. Suppose you're given a task that make a machine learning model that will become expert in recognizing iris flower. And you're given this data right here. Now this data actually has sepal length, sepal width, petal width of different species of your iris flower. There are three different types of species of iris flower. There's a versicolor, there's setosa, and there's a virginica. So each one of them, they have different dimensions, sepal dimension and petal dimension. So your task is to create a machine learning model that will take this input, sepal length, sepal width, petal length, and petal width, and it will make a prediction on what type of species that is. So the general idea is this. First, you collect your data. Second, you split your data into training and testing, and you feed the training data to your model. It becomes trained, and then you test your model. You evaluate how good your model is by testing it against your testing data, this right here. And then you compare it. You compare your the prediction value with the actual value that you gathered from the test. So this is the general idea. So the first thing I do, I import pandas as PD. I also import load iris. This function will allow me to load this data set. I load the data set and I create a feature space. This is my feature space. X refers to feature space. And I also create the target. This is what I'm trying to predict. And then I want to see the shape. I want to know how many rows and columns do I have. And I also want to see the classes. So in this case, there are total 150 rows and 4 columns. In other words, four features. And your classes are Setosa, Versicolor, Virginica in this dataset. So this is how your dataset looks like. This is just a sample taken from the iris flower dataset. This dataset has a total of 150 records. It contains records for 3 types of flowers, Setosa, Versicolor, Virginica, and each one of them has 50 records. Now in machine learning terminology, this part right here is referred to as features. X is referred to as features. Another name for that is independent variables. Your Y, this right here that you're trying to predict, that is called target or response or label. This is a dependent variable. So Y is a function of X. That is why it is called dependent variable. Then the step number 2, you are going to split your data into training and testing. So in this particular case, I'm importing my train test split method. I'm feeding X and Y to that, which is this right here, feeding my data. And this is going to split your data into 4 parts: X training, X test, Y training, and Y test. I want to see the shape of my training. In this case, the size of my training is 120. In other words, there are 120 rows in training and there are 30 rows for testing. So now your X and Y, they are split into training and testing part. In other words, there will be a total of 4 parts now. So this is your X. This has been split into X train, where that would be this part right here. And then X test, that would be this part right here. Likewise, your Y has been split into Y train, that would be this part. And Y test, that would be this part. Now step number 3. Now you train your model. So in order to train your model, you feed X train and Y train to your model. So in order to train my model, first of all, you want to pick up a model. So I picked up random forest classifier. This is the model I'm using. And in this case, I'm specifying some hyperparameters over here. And then I'm training. This particular method does the training part. So in this case, I'm feeding X train and Y train. That would be these right here. Now, depending on the size of your training data and also on the complexity of your machine learning model, this could take anywhere between few seconds to even up to days in order to get trained. Now, in order to train the model, I'm feeding the training data. That would be this data right here, this part. This is your training data. This actually is fed to the machine learning model in order to get trained. This part is not fed to the model in order to get it trained. So this is not part of your training data. So after my model is trained, I want to see how exactly it does on one of the samples. So this is one of the sample value. This one, the first one refers to sepal length. The second number refers to sepal width, and the third and fourth refers to petal length and petal width. Then I convert my sample into the data frame, into the required format, because this was the form that was used in order to train the model. I give it to the predict method. This is an inbuilt method. I feed the sample df to that, and it makes a prediction right here. Then I print out a prediction and also print out the class names. So in this case, there are three classes: class 0, class 1, class 2. And it made a prediction, and the prediction is class 2. So in other words, this right here is sample. It refers to Virginica, this one right here. Now the step number 4, I feed the testing data to my model. In this case, I'm feeding X test, and it makes a prediction. And let's say the predictions are Y predict. So this particular line of code right here, that's what it does. It takes the X test and it makes a prediction, and this prediction is stored inside this variable Y predict. And the step number 5, here I compare my predicted value with the actual Y test value. So that gives me a sense of how good my model is. So in scikit-learn, I'm calling this function accuracy score. In accuracy score, you feed your Y test. That would be this right here. You feed this value, and also you feed the Y predicted value. That would be this value right here. So it's going to compare both of them, and it's going to tell you how accurate your model is. In this case, it's telling me that it's 90% accurate. In other words, it got 90% right. So what I just did was I fed this part of the data right here. This is my X test, and it gave me the model made a prediction. And let's say the prediction is Y predict. And then I compared my predicted value against the actual test value right here. And by comparing it, I could tell now that how accurate or how good my model is.